I'm very pleased to host this webinar that will be focused on resilient transportation infrastructure. Very briefly, I'm Wee Youssef. I'm a professor in the School of Public Service here at Old Dominion University. I'm also a member of the board of STPA. So thank you all for those of you who are members of our association. Thank you for being members, and thank you for joining us. And if you're not a member of STPA, I encourage you to learn more about the Section in Transportation Policy and Administration of ASPA, and we would love to see more members join us. As you can see kind of very quickly, my research kind of looks at various issues at the intersection of transportation planning, coastal resilience, and disaster management. And I'll talk a little bit about resilient transportation, but I also, in another capacity, I host and organize the Hampton Roads Sea Level Rise Flooding and Adaptation Forum, which is where I first learned about the Virginia Department of Transportation plan for resilient transportation. So I also, in a prior life, way back when, went to school at the University of Kentucky and worked at the Kentucky Transportation Center, which is where Ben and I first met as graduate student colleagues. So I'm excited to have Ben and Chris here joining us. And very quick, let me just kind of move on to the next slide. So when we talk about transportation resilience or resilient transportation and transportation infrastructure, we generally think about resilience of the transportation infrastructure to the impacts of hazards. So here in coastal Virginia, in Hampton Roads, we're always worried about flooding and roads that are subject to flooding, but obviously other parts of the country have to deal with other types of extreme weather, ice, snow, landslides. So we generally think about how the transportation infrastructure itself is resilient to the impacts of hazards. But as somebody who studies also community resilience, we also note that resilient transportation infrastructure plays a really important role in mitigating the disaster impacts. So thinking about transportation infrastructure as evacuation routes for hurricanes, as evacuation routes for wildlife, but also as a way to connect the community with the healthcare system, for example, to ensure overall community resilience. So just really thinking about resilient transportation, not just about the infrastructure itself being resilient, but how that infrastructure, because of its resilience, helps mitigate disaster impacts, but also then helps support broader community resilience. I was asked to kind of briefly share some of the local perspectives because some of the work that I do focuses on resilience planning for rural localities across coastal Virginia. And I think what I want to just briefly highlight is that one of the big challenges is for local localities is this idea of their ownership and the responsibility for improvement, maintenance, and repair of local roads. We've seen over the last 3 decades this devolution of ownership and responsibility of roads and infrastructure to local levels that come with sometimes informal mandates to improve resilience or to maybe use specific approaches to infrastructure planning and programming, but that doesn't necessarily come with the needed resources or the authority to raise needed funds for the improvement, maintenance, and repairs of this infrastructure. So for example, we might think about how localities are now told that they need to consider more green infrastructure as a way to manage water, for example, or to as a way to kind of mitigate some of the flooding impacts. But that doesn't necessarily come with the needed expertise or the additional cost that might come, that might be needed to program more for that green infrastructure. I think more importantly, I just wanted to, from the local perspective, highlight that all the impacts are local, whether it's a state road or an interstate. The impact is felt at the local level. And with that comes this additional challenge of thinking about how do local governments improve the resilience of their roads and bridges when they don't actually own those roads or bridges. So in Virginia, for example, in coastal Virginia and the rural localities, a lot of the counties struggle with how do we manage, for example, the ditches. Obviously, you have that picture on the slide. How do we manage the ditches on roads that are owned by the state? Because when those roads flood, they still impact the local residents of the county, but the counties themselves do not own these state roads, for example. So how do you balance the need for improving resilience for issues and experiences that are local to residents at the local level, while managing kind of the challenges of infrastructure that is not owned by the particular locality. So just wanted to use that to kind of introduce some of the challenges, some of the issues. I'll give you a little bit of a flavor for why we need to be thinking about the resilience of our transportation infrastructure. We have Chris Berg, who's the Director of Sustainability with the Virginia Department of Transportation. And in this role, Chris is supporting VDOT's efforts to lower emissions and improve air quality, increase resilience to flooding and other hazards, and strengthen land stewardship across the transportation system. Chris holds master's degrees in environmental studies and public administration, and he previously worked with the Army National Guard on renewable energy and energy efficiency initiatives. Chris will be presenting first, and then we will have Ben Blanford present next. And Ben is the program manager for the Kentucky Transportation Center's Resilient Systems Program area and has worked there since 2006. His research centers on transportation resilience to climate and natural hazards and transportation safety and behavioral analyses. Dr. Blanford specializes in geographic information systems. He teaches GIS in the civil engineering program at the University of Kentucky and is an active planning committee member for the ASTO GIS and Transportation Annual Symposium. Dr. Blanford holds a PhD in geography, which he completed at the University of Kentucky in 2015.
So yeah, thank you all for having me. My name's Chris Berg. I'm the director of the Virginia DOT's Sustainability Office, which includes our resilience program, which I'll be telling you about today. So just for some context on where our resilience program sits within the Virginia DOT. So it's housed in our Sustainability Office, which was established in 2022 in our Environmental Division, with the goal of really balancing, with the goal of really balancing transportation needs with emerging environmental issues. So things like climate change and habitat management. So the office is organized around really how the three pillars that really define transportation sustainability for VDOT. So which you can see here. So the first being our decarbonization program. So working to reduce emissions from the transportation sector. Second pillar, which I'll be focused on today, is our resilience program. So that's more on the climate adaptation side. So looking at things like vulnerability analysis and adaptive design. And then our third pillar is our land stewardship program. So thinking about how we can best manage the habitat and the environmental benefits from our right-of-way of our transportation assets. So to zoom into our resilience program, so just some background here, and this won't be news to those on the call today, but in terms of why we're doing this resilience work in the Department of Transportation, as we've seen in the past couple of weeks, we are seeing an increase in a lot of natural hazards across the country. So we're seeing increased temperature, sea level rise, increased precipitation, extreme weather events, and rock falls and slope failures. And these natural hazards are impacting, in turn, our transportation assets. So we're seeing increased asset deterioration and failure. We're seeing challenges to our operations, our maintenance, and our emergency management of our roadways. And on the environmental side, we're also seeing shifting migration patterns and impacts to natural habitats, which impact some of the regulatory aspects of our roadway projects. So in addition to kind of the natural drivers, as we mentioned, we do see kind of the policy mandates as well that's driving this work. So starting in around 2018, Virginia started to see an increase in executive orders and state level legislation related to resilience. So starting with kind of some general directives for state agencies to account for sea level rise, and then ultimately directing your Department of Transportation specifically to address resilience in all of our projects going forward. So we have now incorporated that into our planning, as you see on the right. So our strategic planning for the state transportation sector speaks to the need to address flooding and increase the resilience of our assets. So in order to do that, in 2021, VDOT really began to tackle the concept of resilience. So our first step was to really just define, skipping ahead. Our first step was really define what resilience means to VDOT. So we view it as the capability of a transportation project or strategy or asset to anticipate, prepare for, respond to, and recover from a significant natural threat or hazard with minimum damage and disruption to the transportation network. So we've really been approaching this. Once we have that defined, our next step is to really incorporate that concept across everything that we do. So starting with planning, moving into project development and delivery, maintenance and asset management, and operations and emergency management. So that's really been the work of the past couple of years that we've been undertaking in the department, which I'll be going over today. So in terms of incorporating it throughout our organization, the first step, as I mentioned, was really the establishment of our Office of Transportation Sustainability, which serves as kind of a central hub for these resilience efforts throughout the department. In addition, on the right, you can see kind of how we've broken out resilience across the whole department. So we have a resilience steering committee that meets monthly or quarterly and is made up of staff from offices across the department. So really bringing in all the different business practices, all the different aspects of our transportation agency. And then that staff level work funnels upwards towards our administrators committee, which is made up of division leadership. And then that in turn funnels up towards our agency-wide leadership for final decision making. And then on the left, you can also see our Virginia Transportation Research Council, which I'll touch on a bit. We've really been relying on them. We've stood up kind of a dedicated resilience research effort to make sure we have the best available data and tools and information to make these decisions. So really the fundamental framework that's driving all this resilience work for us is our resilience plan, which was offered in November of 2022. And on the right, you can see the 6 main objectives that really define this plan. So again, this is really kind of a framework for how we can instill resilience across everything that we do. And I'll briefly go through each one of these for the rest of the presentation. So you don't need to read them all here. So first off is really, as I mentioned, it's making sure we're making data-driven decisions. So we're fortunate to have a significant internal research council within VDOT that is able to do multi-year research studies. So we currently have 16 individual research projects focused on resilience, which you can see on the right here, focused on everything from historical flooding data to impacts on materials and different transportation operational management technologies that we can look at. So this is driving a lot of our work, again, making sure we have the best data and the best practices really from across the industry. So our second strategy here is coordination and outreach. So it's, as I'm sure folks are aware on this call, it really takes all industries, all sectors working towards something as big as resilience. So stakeholder engagement has been a key part of what we do. So presenting to groups like this, but also taking part in working groups, in planning committees, in research projects, really just making sure we are in alignment with local, regional, state, nationwide efforts on resilience. So our third strategy, this is really starts to get into the meat of our work and something we've been working on most of this year. It's really to identify what of our infrastructure is at risk to natural hazards. So we've really been working on developing a methodology to first analyze those risks, but then visualize them through a mapping tool. And this will allow us to really make sure we're applying resilience concepts in a methodical way, really focusing on where our biggest needs are. So the methodology that we're using here, I won't go too in depth into this, but just at a high level, we first look at exposure. So is an asset actually exposed to a hazard? We then look at sensitivity. So if it is exposed to that hazard, how sensitive is it? So is a roadway able to deal with a certain amount of precipitation before it actually floods? And then third is adaptive capacity and criticality. So adaptive capacity, again, how able is that roadway or the surrounding roadways able to deal with flooding or storm surge? And then how critical is it to the overall transportation network? So are there a number of available detours, or is it a potential bottleneck for a community? All of those indicators are added up to get our overall vulnerability score. So this lets us look really statewide and see where we are most vulnerable to precipitation, riverine flooding, landslides, sea level rise, etc. So at a high level, this chart here kind of shows how we will apply this analysis. So again, we will look at an individual asset, whether we're planning a project or planning to do some maintenance, and we can see how vulnerable is it, low, medium, high. If it is highly vulnerable, we will then consider resilience practices. Or if it is a critical asset, we will also consider resilience practices. So once we've identified those individual practices, we will also run that through a benefit cost analysis, which I'll touch on briefly in a future slide. And then ultimately, if it's cost beneficial to take that action, we will apply those resilience actions. So this is just a quick snapshot of what the tool looks like. So you can pick a number of different scenarios. You can pick what year you're planning for. You can pick a geographic area. You can choose a particular hazard to focus on. And then you'll see visualized on the right here, certain roads with low risk will be in green, and then red will show where we're highly at risk. So once we've identified where we're at risk, the next step is this fourth strategy here to develop those resilience practices. So this is kind of our resilience toolbox that really lets us draw on the different solutions that are out there. And the most important one of those is really our adaptive design criteria. So this is just the way we plan and design and construct our roads across the state. So from pavement and geotech to our drainage and our structure and bridge, we are looking across all of these manuals and guidance documents to see what updates we need to make to account for the increases in precipitation, the changes in precipitation, sea level rise that we're seeing now and in the future. You know, a lot of our bridges are built to 75 or 100-year lives. So we really need to be thinking about what's the best projections we have for example, what the sea level will be 100 years from now. We're also looking at a number of additional physical enhancement practices, things like flood barriers, flood attenuation, enhanced stormwater design, slope stabilization. So in addition to kind of those hard construction practices, we're also looking at, because we understand we can't build our way necessarily out of flooding in all areas. So we also need to consider more operational or maintenance or emergency management practices. So these are things like targeting enhanced maintenance ahead of a weather event, developing better early warning device technologies to let us know if a river is rising above a certain amount or if a drainage system is being overwhelmed. And then also thinking through things like our redundancy. So do we have detour routes in place? Do we have communication channels where we can communicate to the public if we know a road is likely to be flooded? And then finally, we're considering administrative and policy practices. So how do we need to change the way we procure materials and manage projects in light of resilience? And one final kind of tool in the toolbox that I'll mention, since this work is housed in the environmental division of VDOT, we're focusing not just on gray infrastructure, like you see on the right, so your traditional concrete and riprap, for example, on this seawall, but also looking at more green solutions, nature-based solutions, like you see on the right, where you have also a constructed marsh that includes some planting and also has a traditional breakwater to reduce that wave energy and prevent erosion. So thinking about how we can rethink the way we harden our road infrastructure to make it more resilient in the long term, while also kind of providing additional ecosystem benefits. So again, I won't go too much into this, but these are some of the concepts we're looking at applying. So things like vegetated revetments, marshes plus breakwaters, and marshes plus kind of a sill there you can see. So it's really providing a hybrid, bringing in some of that traditional gray infrastructure to harden that asset, but then trying to also work with the natural environment to restore marsh ecosystems that can also provide resilience benefits. And then our final couple strategies here, as I briefly mentioned earlier, once we've identified these practices, we need to run them through a cost benefit analysis to make sure it's actually worth it in the long run to take these additional resilience steps. So we'll consider things like the impacts on traffic, the impacts on travel time, the impacts on emissions, impacts on vehicle maintenance. So we'll consider that against both the upfront cost of the project, but also the long-term operations and maintenance costs to really see, are we providing a benefit to our drivers as well as to our long-term maintenance and construction budgets. And then finally, our sixth strategy is really just thinking through how does the concept of resilience and planning for resilience impact the way we fund projects. So thinking about our current investment processes, our current funding programs, how will those be impacted? And then also looking to identify new sources of funding. So there's significant new federal funding available, namely the PROTECT program, which is managed by the Federal Highway Administration, which is providing increased funding for us to apply these resilience planning concepts. So just very briefly, the PROTECT program was authorized under the Infrastructure Investment and Jobs Act to ensure transportation resilience to natural hazards. So Virginia is receiving almost 190 million over the first 5-year life of the program. And this money can be used for planning activities like the development of our resilience plan, for resilience improvements on assets, can also be used for looking at community resilience. So things like evacuation routes and detour planning, and also to harden at-risk coastal infrastructure. So we've used this initial funding for, again, our planning, a lot of the research that I've mentioned. We've used it to conduct some internal training on resilience, to inventory our evacuation routes and our drainage, and then ultimately to start hardening and elevating bridges that we know are located in vulnerable areas. PROTECT also has a grant component that is open to state agencies, MPOs, and local governments. And we did apply for and win a grant this past round. So we'll receive almost $5.5 million. And this project is kind of a pilot technology focused project on the tidal region of Virginia. So we'll be focused on installing a weather and traffic monitoring system. So this will really help us to plan ahead for potential weather events and really monitor in real time how our assets are performing in a flooding event. And again, this will really serve as a pilot just to see, can we apply all these various technologies, whether it's closed circuit cameras, dynamic message signs, flood sensors, stream gauges, and can we incorporate these into our current traffic operations systems and apply the best practices statewide. So that's all I have today. Just to wrap up here, our next steps. I mentioned some of the pilot projects we're working on. That'll be happening over the next couple of years, while we also work to finalize those adaptive design criteria that I mentioned, our resilience toolbox. We'll also be working to finalize that at-risk visualization tool that I mentioned so we can see spatially where we're most at risk. Finalizing our cost benefit analysis to make sure we're making wise long-term investments. and ultimately evaluating how we can incorporate resilience into our funding and other policies. So that's all I have today. Thanks for your time. And here's my contact information as well as the contact for our resilience program manager. So I look forward to any questions you might have at the end of the meeting today. Thank you.
Thank you so much, Chris. And then I will invite Ben to pull up your presentation.
Is that coming
Looks
through?
good, Ben.
Okay. As we mentioned earlier, we were both grad students here at UK. It wasn't that long ago, was it? Just a couple of years, right? Maybe more than a couple. But thank you for inviting me to do this. I'm at the Kentucky Transportation Center at the University of Kentucky. So the research center here is, it is housed at UK, but we are kind of the official, unofficial research branch of the Transportation Cabinet, which is the state DOT. So much of the work we do is with the Transportation Cabinet. So what I will be presenting on here is partially from KYTC's perspective, and then partially from my perspective as a researcher doing a lot of projects with the cabinet. So context of the problem, this overview of what I'll be covering in my slides here, the context of the problem, some of the KYTC strategic planning efforts that are have been undertaken and are still ongoing, some data improvements that we've implemented, and then some of the research activities that have helped support all of the above, including a statewide vulnerability assessment. We did an FHWA pilot project on resilience and asset management, some climate modeling, and then taking the results of that climate modeling to calculate future transportation impacts. And know that picture there, it's not a recent picture, definitely an old picture, but give you an idea, we've come a long way, but we still got a long way to go to develop resilient systems to the weather we face. Okay, so context of the problem, just as a little bit of background, Kentucky had two kind of traumatic events that occurred in kind of short succession. So in December of 2021, Kentucky was subject to a pretty massive tornado outbreak. As you can see in the weather map there, the tornado actually touched down in Arkansas. It was a Category 4 tornado. It stayed on the ground through Arkansas, parts of Tennessee, and then all the way from Western Kentucky, all the way up into Central Kentucky before it finally left the ground for good. On the way, it leveled many communities, including the towns of Mayfield, Princeton, Dawson Springs, and Bremen. It destroyed 15,000 buildings and homes. 93 fatalities overall, including 70 in Kentucky. Over $3.5 billion in damages. And that weather map there just shows what there was actually more than one tornado. That was just the biggest one. There was another one that actually hit the city of Bowling Green in Kentucky, which is the third largest city in Kentucky as well. So that occurred, and as we were still reeling from the impacts of that and responding and recovering, then the following summer, Kentucky was subjected to Eastern Kentucky, some pretty massive flooding. So this was described as a 1,000-year event. Upwards of 14 to 16 inches of rain fell across a narrow swath of area over the mountains of Eastern Kentucky. If you can imagine that much rain, if you've seen any of the pictures in the news lately of what's going on in North Carolina from the hurricane, we had a similar occurrence here in 2022. So the flash flooding in the valleys led to 43 deaths, widespread catastrophic damage. You can kind of see some of the pictures there of houses just going down, running into bridges, roads just completely collapsing. Recovery costs $1.5 billion or more with that as well. Over 160 bridges were damaged or destroyed. So in the wake of all of this, that there is certainly a heightened sense of urgency in the Commonwealth of Kentucky to better prepare ourselves for future events. You can kind of see here, this is more of a long-term trend of extreme weather. These are weather-related disasters that have been declared in Kentucky over the years since 1980. And you can see the frequency of them kind of going up over time, and that's due to a number of factors, but certainly the increased occurrence of extreme weather is the major driver of that. You see of those flooding, 75% of them involved flooding, wind was involved in 61%, landslides 42%, winter precipitation, that's like ice and major snowfalls, 17%, and wildfire, a little bit of that as well. And then, of course, those don't add up to 100% because any one event can feature multiple of these types of hazards or these types of impacts. So when we talk about transportation resilience, I often like to put this slide up just to emphasize what we're talking about and what we're responding to. So climate change and extreme weather, present a growing risk to the safety, reliability, effectiveness, and sustainability of our infrastructure. And these impacts are expected to intensify in the coming years. Transportation infrastructure was designed to handle a broad range of impacts based on historic climate, but the climate is changing and less is known about how our infrastructure will respond to future impacts. So a lot of what we're doing is trying to determine that and best prepare ourselves. So I mentioned some of the strategic planning efforts going on at the Transportation Cabinet. I do want to highlight the asset management plan. First of all, this is a federally required plan that's updated every 4 years. And among the components of the plan is to establish goals, objectives, and strategies for preserving KYTC assets. And when we say assets there, we're mainly talking about pavement and bridges. So this is very much a road-centric plan. There's life cycle planning in there, including deterioration curves. I think some of that was mentioned in our Virginia presentation that went before mine here. And also some discussion of preservation treatments and costs, and then managing risk and resilience. And so we include a risk register, which is kind of a, envisioning what are all the potential risks that might occur and what are the likelihood and how might that impact our system. And then it also does identify some process improvements for the cabinet. And the other strategic plan I want to highlight here is the resilience improvement plan. So this came out of the bill, the bipartisan infrastructure law. These are not required by federal highways, but they are recommended. And as the last presentation talked about the Protect Funding Program, if you have a resilience improvement plan approved by FHWA, then that allows for a lower cost share towards those Protect funds. I mentioned those major disasters that occurred in Kentucky. In the wake of that, there was a sense of urgency to begin acting. And so one of the first things we wanted to do when we saw this opportunity was let's get a plan together and let's get it out there immediately. So ours was approved in summer of 2023. We were actually the first state to get federal highway approval for our resilience improvement plan. I think last I heard there were about 12 to 15, my understanding. This plan draws pretty heavily from previous research, some of which I'll talk about in the next few slides. And so it's, in some ways, it's kind of an academic document because it draws from academic research on vulnerability and resilience. So there's a lot of updates that can still go into this plan. We're treating it as a living document to continue to improve this sort of strategic planning effort. Okay, so one of those processes improvements that I talked about, this was something that I've been working with the cabinet on this since I want to say 2018 or so. One of the things we identified was that there was really no data on what's happening in the state in terms of climate impacts and disaster and where is the damage occurring, how much does that cost. There's the FHWA ER program, which is emergency repair. And so we had some documents, that are submitted through there. This is an example of one of those here. This is from 2012, but it was just in PDF form. It was really just a scanned document that was in PDF form that we found. And I think this one came from maybe District 4 or something like that. And so we identified, well, we need to compile all the data we can. And also going forward, we need to continue to track that. And I have a strong GIS background, so my interest is certainly to getting this into GIS. get as much data as we can, and start building a longitudinal database. So then we can begin to perform analysis over time. So the data that goes into this database now, originally we was just these like PDFs here, like you see here. And fortunately I work at the university and have access to student labor to help digitize these types of documents. So FHWA, or FEMA, also has a reimbursement program for transportation agencies, and Kentucky utilizes that from time to time as well. And then within the transportation cabinet, there's a system called OMS, which is Operations Management System, I believe. And within so OMS tracks costs associated with different activities. And you can assign, in the case of like a weather event, you can assign what they call an emergency code. And then all activities, so labor, material costs, whatever, all can be assigned to that code. And so you can track everything that was expended to respond to that emergency event. And so we've been able to compile all of that, and we got it through 2022 anyway. We need to get 2023 data in there. Earliest records are from 2009. At this point, we have over 10,000 unique records. You can see a dot here on the map for almost all of those that we were able to geolocate. The data includes, where available, the route and mile point, where the disaster occurred, when it occurred, the characteristics of the emergency event, the type of damage, the type of repair work, and then an estimated repair cost for that. And when you start breaking it out now over time here, you see beginning in 2018, those costs really started to balloon. Kentucky suffered, it was pretty much repeated flooding in eastern Kentucky from 2018 to 22, really culminating with those massive floods we had in 2022. It's really wrecked the maintenance budgets, and it's really gotten a lot of people's attention. And then when you're able to compile all that data and show it graphically like that, then it really gets people's attention there. But you see it's up over $100 million on average in the most recent years. And then how's it spread out across Kentucky? You can see these bars to the right here. Those are the mountainous areas of eastern Kentucky. Not surprisingly, those have the highest impacts. When you dump a bunch of rain over mountainous terrain, all that rain falls to the valleys and it accumulates and it accelerates. And that's where the roads are, that's where the communities are. And so they suffer the most damage from that. So no surprise there to see that's where the most damages are. Also with the database, you can do some, drill down. And so in this case, you're looking at in Floyd County, this is in eastern Kentucky. Each of those dots represent someplace where something happened that we have documented in our database. You can see the mile point, estimated costs, and a description of what happened. And then if you want to look at a little bit higher level, say at the district level, say you're looking at District 12, and you want to say, what are the highest impacted routes in District 12? So in this case, US 460 and Pike counties had 6 events where they suffered damage over $7 million. And you can kind of see that we've done this for each of the 12 districts. Okay, I'm going to I have some research summations here. I'm going to kind of go quickly through some of these because I don't want to take up all of our time here, but we did a statewide vulnerability assessment 2015 to 2017. This was kind of the first foray into this area for the transportation cabinet and myself. This is where we kind of began building our knowledge base. This is we looked at all types of different threats here: flood, wind, drought, dam failure, wildfire. These are all from the emergency hazard mitigation plan, the statewide. Then we sort of identified likelihood and consequence, and basically darker red means higher likelihood and higher consequence, and the lighter colors mean less likely or less consequence. We also did workshops at all 12 districts to meet with the personnel there to get kind of that local knowledge, meet with district engineers, meet with maintenance personnel. We would sit down with big maps and place them out and say, hey, show us where you're having problems, and start gathering all that data, incorporate that into an overall vulnerability assessment of the state. In addition to the desktop data gathering on as much as we could on that as well. And then compiled all of that, and you can kind of see how the summation of that for the different types of roads and bridges and the threats there. I won't go into the details on all that, but this is all research that we have published. We also did a pilot project with Federal Highway Administration called Asset Management, Extreme Weather, and Proxy Indicators. We were one of 6 states involved in that. And for our project, we did a composite bridge sensitivity index to flooding. And we also did some modeling to look at the effects of extreme heat on pavement performance. And then we identified process improvements, and that was completed in 2019. And I'm going to skip ahead from there to project we just completed here, just completed over the summer. This was a multi-year effort to look at future climate impacts involved with precipitation primarily. So I mentioned that damages database and all the data we have, we wanted to start doing some analysis of that, and we knew we could get a hold of some really good climate data. And we wanted to determine, can we take that climate data and begin identifying probabilities of different precipitation thresholds? So if you get an inch of rain in a day in Eastern Kentucky, what's the likelihood of damage occurring? What about 2 inches? What about 3 inches? And so forth. And if you do have damage, what is the magnitude of that? And you can kind of see what an illustration of what that looks like here. This was from 2021, where you had, that's the rainfall associated with that storm event, and each of those dots indicates somewhere where damage occurred. And you can see it pretty well aligns with the rainfall totals. In Eastern Kentucky, you're just going to get more likelihood because of the mountains. And there's another one as well. This is from 2020, same idea though. So what we did is, for all of the data points that we had, all 10,000 where we could, we identified how much rainfall was associated with the event that caused that damage. So we're looking at flooding, we're looking at landslides, because they're most frequently triggered by rainfall. And you can see for each of the districts here going across the state now, the probability of damage occurring when you have that type of rainfall in 24 hours. And for some of these, when you go up to 5 inches of rain, we don't have fields in there. It's because we don't, in our sample size, we didn't actually have any weather events where that much rain fell in a day. But not surprisingly, as you go across, the likelihood goes up, and as you go down, the likelihood goes up as well. Because generally, as you go down, that means from west to east in the state, and the mountains are in the east. And then you can also look at the magnitude. So that was the probability. Well, say something happens, then how impactful is that? And we grouped districts for this according to the gradient, the average gradient across the entire district. So districts 1, 2, 3 have the flattest gradient, and 10, 11, 12 have the steepest gradient. And you can see how closely, when you define it that way, if you get 5 inches of rain in districts 10, 11, or 12, you're looking at $36 million in impacts on average. So it's a pretty rare event to get that much rain, but when you do, you're going to have trouble. And that's what we're able to determine from this. So but then we have this data. We wanted to look at, we can also get future climate data. Let's look at, if we know the likelihood of damage occurring, let's look at the future. What are the projected likelihoods of these precipitation events occurring? So here you have change in precipitation by county. We also did it for, well, just real quick. If you go down to the bottom down here, average number of days, it goes up by 7%. Average days of 2 inches of rain up by 37%. So each of these, you are seeing an increase. Kentucky is projected to get wetter with more extreme precipitation events. The same is true with heat. This is the average change of the number of days of greater than 100 degrees. Western parts of the state are generally hotter than eastern because, they don't have the mountains. You can see then the percent increase there for the days greater than each of those thresholds actually goes up quite a bit there. So taking all that data, applying those likelihoods and those magnitudes, then we look at the historic period, which was 1980 to 2004, to the projected period, which is 2026 to 2050. We did it for each of the district, but statewide, we're looking at a 31% annual increase in expected impacts due to precipitation. So basically, we're looking at, on average, $71 million in 2023 a year. And that's a 31% increase over the historic period. So the goal of this is to, if we can get to this point where we can start showing the dollar figures, then, you know, in Kentucky, the political climate is different than maybe some other places. There's a little bit of hesitancy to accept some of the science on future climate. And so if we can start to put together numbers like this and people can see what's happening to maintenance budgets in real time, then people can start to, you know, be more receptive to actually implementing some resilient solutions. I'm gonna, yeah, but this is something we're working on now, the cost of inaction in terms of not, you know, when you talk about cost benefit, your benefit is avoiding what's going to happen, right? Or mitigating against what's going to happen. The cost of inaction is what you expect from these impacts that we showed. Currently, what we're doing now is taking the results of that. We're actually working on a project prioritization methodology that's going to be implemented by the cabinet to use for that protect funding to identify projects that would most benefit from resilience improvements. And seeing that presentation for Virginia, I see you all are pretty far along in terms of the toolkit you mentioned for resilience solutions. I'm hoping Kentucky can catch up with you all there in the not too distant future, because that's where we will be here in the coming years. So I'm going to stop there, and hopefully we still have a few minutes for questions.
Thank you, Ben, and thank you, Chris, for the presentation. We do have a few questions already in the chat, so we'll get to that. If you have questions for Ben, once we get to these, please ask them, or you can put them in the chat. But this is a question for maybe both Chris and Ben. How has the politicization of climate resiliency affected both the funding and public support for these types of resilience projects?
Yeah, I'm happy to start. I think that's an important question. You know, I think in Virginia, we see more politicization of kind of climate mitigation, honestly, than we do more on the adaptation side. So I think, you know, folks can have discussions over the kind of the long-term causes of the hazards that we're seeing, but you know, I think the science is pretty clear that we are seeing rising sea levels on Virginia's coast, and we are seeing changes to precipitation patterns. So I think, you know, we have seen pretty good support across the political spectrum for resilience at the state level, at the federal level. So I think we have pretty widespread support. Like I said, just given the impacts we're seeing in our communities today. So,
Ben?
Yeah, I would say it can certainly depend on the administration that's in place at the state level. We've currently have a very receptive administration that's really helped us make some progress in this area. Knowing that's not always been the case, and that's not always going to be the case in the future. But I would also say, you know, I've mentioned those big major events. Everybody in the state knows someone that was affected by those. And so, you know, even at the community level, if you say climate change, people might be a little, you know, shut you out. But if you talk about specific events, you know, extreme weather that people have experienced, that everybody can nod their head and say, yeah, I get that. So we try to frame it in those like that as much as possible.
All right, so we have a question from Giselle that asks for the VDOT resilience plan, to what extent is the plan coordinated with the department's transportation asset management plan?
So our asset management folks are involved. I mentioned our Resilient Steering Committee. We do have representation from our asset management office. on that steering committee. I think we've taken some initial steps there on incorporating resilience into our asset management planning. I think we'll continue to kind of focus on that in future years. I think there are some other things that are more of a near-term priority right now in terms of just the data. Some of what I talked about of figuring out where we are at risk first. So I think once we get a better handle on that over the next 6 months, 12 months, I think we can think better about how we need to adjust our asset management in light of those vulnerabilities that we're trying to identify right now. So it's definitely something we know is important, and we'll continue to work on it in the future.
And Chris, there was a clarification question as to whether the executive order only applied to the DOT or if local agencies are also required to follow.
So I think the executive orders I referenced were focused on state agencies. And then there was actual legislation a few years ago that was directed at the agency itself, at the Department of Transportation, to ensure that anything built by our agency is resilient. So that mandate does not at this point kind of trickle down to the locality level. I think ideally, some localities do look to VDOT in our design standards. So some of our hope is that with us taking these steps to update our design standards to account for resilience, that'll give the localities kind of a direction to follow suit.
All right, thank you for that. And then John had a question for Ben. We know that an ounce of prevention is worth a pound of cure. So it's best to pay the cost of prevention. So do the recent events provide an opportunity to invest in resilience?
I would say the tragic events, because it's such a huge tragedy, it's in the news a lot and everybody sees it, and it is a reminder to everyone of what can happen and what has happened and what's likely going to continue to happen. So it certainly provides an opportunity to, remind people that this isn't going away. I think at the Department of Transportation level, that I think they're pretty well on board with this, from the top to from the top down. There is a lot of work going on right now to invest in resilience and utilize some of that protect funding as best we can. And unfortunately, events like that with the Hurricane Helene, it's just another tragic reminder of what's going on out there.
I will very much like to thank all of you for joining us. Thank you, Ben, for presenting, and Chris for joining us as well. And I hope that you will make this the webinar series something that you'll come back to more regularly once we institutionalize it. Thank you so much.